Adding and subtracting with complex numbers is pretty much the same idea as when you have learned in the past to add and subtract with variables. The basic concept is combining like terms. When you are adding with complex numbers, or subtracting, adding or subtracting with complex numbers, you are looking to combine the real parts together, whether that be with addition or subtraction, and then you will look to combine all the imaginary parts together. As you would expect, your answer is probably not going to come down to one single number unless one of the two parts or one single term unless one of the two parts cancels out. More than likely, you're going to end up with an answer that has both a real part and an imaginary part, and you will need to make sure that that is in standard form with the real part coming first. So let's take a look at an example here. We've got 4 plus 7i plus 1 minus 6i. Since it is addition, we really don't need those parentheses there. If you want to be technical, we look at this as like a positive 1, and we would be distributing that positive 1 to the second parentheses, but positive 1 times anything is just that number, so there's really not a whole lot we got to worry about there. We can basically just rewrite this problem, this expression, without any parentheses. Once I do that, now I'm ready to combine like terms. I see a 4 that's a real part, and I see a 1 that is a real part. 4 plus 1 would give me 5. I also see a 7i, a positive 7i, that is an imaginary part, and I see a negative 6i, that is an imaginary part. 7i minus 6i would be 1i, or just I. That would be your answer. Subtraction is only slightly more complicated. If we look at this second example, we're taking the quantity 1 plus 8i minus the quantity 3 plus 12i. We do have to be careful with this subtraction. We kind of want to treat this as a negative 1. We want to look at this as a negative 1 that we really do need to distribute to make sure we are subtracting both the 3 and the 12i. Now the first parentheses we really can just drop off the parentheses and rewrite first quantity. But negative 1 times 3 would be negative 3. Negative 1 times 12i would be negative 12i. Now we can look to combine like terms. We've got a real part of 1 and a real part of negative 3 that I see. 1 minus 3 would be negative 2. We've got two imaginary parts of 8i and negative 12i. 8i minus 12i, 8 minus 12 is negative 4, so we'd have negative 4i. We do have the real part first and the imaginary part second, so this is in standard form. Multiplying complex numbers, much like adding and subtracting, is basically the same concept as when you're doing it with any other variable, even the ones that don't have a specific number they equal. The only main thing you need to look out for, the main difference, is that if you get I squared, remember we have discussed that I squared is equal to negative 1. And so you can actually change that to negative 1 and continue simplifying. So for an example here, I've got two binomials, two complex binomials, that we would want to FOIL out or multiply out. So 3 times 4 would give us 12. 3 times negative 5i would give us negative 15i. 3 times negative 5 is negative 15. 2i times 4 would be 8i. 2 times 4 is 8. 2i times negative 5i. 2 times negative 5 is negative 10. And I times I would be I squared. So for starters, we go ahead and do what we would do if these were just x's or any other variable, and we'd combine the two middle like terms. So negative 15i plus 8i would give us negative 7i. Right? Negative 15 plus 8 is negative 7. We'd rewrite the 12, but now, whereas usually we would be done when we were FOILing with other variables, we can now change I squared to negative 1, meaning we have negative 10 times negative 1. Negative 10 times negative 1 we know would give us a positive 10. And now we have two more like terms that we can combine. 12 plus 10 would be 22, so 22 minus 7i would be our final answer here. And yes, remember, standard form would mean 22 has to come first. It's exactly as we have it written here for your final answer.